Is there anyone who hasn't been to lightning talks before now? Any new people here today? You all know the score. Cool. Okay, I don't have to labour this. 5 minutes though, and remember to all these speakers down here, if you go past 5 minutes, you will be forcibly ejected off the stage in a appropriate with the code of conduct way. The subjects tonight, I'm really excited about what we're going to hear. I mean, there's C++, yes. There's unexploded bombs. There's testing. There's more than a little hilarity. You're gonna love this. You're gonna love it. So, without further ado, here is your list of wonderful speakers this evening. However, I don't trust ladders. They're always up to something. First up is Giovanni.
Come on. Thank you. I saw it. Okay, so my talk is what if? This is a conversation that I have very often, but I had it last week with a team I'm working with. And I was having a conversation with a team with some QAs, actually QEs, quality engineers, which they do automation, and developers. I was telling them, guys, when you write automation, I want you to work together, QE and developers, and write the automation together with the tools used by the developers. And one guy goes, what if? What if developers have no time to write automated tests? Then I tried to look serious, say, yeah, excellent question. Let's start with a fact. Developers are experts in automation, yeah? Any disagreement? Yeah? Because if you're a developer and you don't know what automation is, I'm going to tell you, leave the room now, yeah? And they went, yeah, okay. Now let's try to answer the question. What do developers do when they don't write automated tests? They write the code, they compile the code. Then they deploy it somewhere because they want to know, does the code work? They deploy it somewhere and run it. Yeah, and the somewhere could be in the clouds, far away. Yeah. There is also an optional step. That is, I run the code, but I'm quite unsure. I write some code, again, where I add some logs, the kind of Giovanni has been here kind of logs. Yeah? Run the code again, read the logs, follow, say, does what it was supposed to do. Great. And then I said, how do you call it? Perhaps it's testing. They went, yeah, it's a shallow form of testing that is also very time consuming. So if they spend the time automating that stuff first, they can actually run it again and again much more quickly. Shall we agree that you are going to work together and the developers are going to write the automated tests? They agreed. And at the end, I also asked a question. Did I say anything wrong by any chance? Disagree with me if I said anything wrong. A brave soul went like this. No, you are right, because he thought I was reading his mind as well. Thank you very much.
Thank you, Giovanni. What do you call a fish wearing a bow tie? Sophisticated. Next up is Tom. All the way over there.
All right. How's this stage work? Right. Nice. I didn't think this thing would be slanted, so. Apologies. All right. Yeah, you can forget all the tech stuff for like 5 minutes. Yeah, because there's plenty more where that came from, I think. So quick backstory, I am a statistical programmer in Exeter these days, but I moved with my family from the UK to France, age 2, and then moved back in the opposite direction, age 14, and then back again to France just before uni, which I did in Exeter, so back and forth. It led to a lot of confusion as to where I myself was from. Where is home? What is home? And that runs in the family, as my dad moved from Peru all the way to Europe at about 18. So it's a thing that we have. So it makes that kind of what's normally quite a simple question needlessly difficult very often. So then I come to uni and I found out about something called the Third Culture Society, Third Culture Kids Society, they call themselves. And I have to look this up because I've never heard this term. And I discover it's third culture, if people don't know about it, it's your third culture if you grew up in a place that is neither your parents' culture nor is it your own national identity. So as someone who grew up with an English mum, a Peruvian dad in the Paris area, like I'm thinking that's a bit of me, right? And so it was. That's exactly how it turned out. I'm connecting with all these people from different international backgrounds over strange things that we shouldn't really have in common, but we do in a very abstract sense. And as I go through kind of my uni experience and going kind of into now, really, it becomes an opportunity to really turn what I thought were weaknesses, like this sense of confusion growing up and a few other things, into strengths. So instead of feeling a bit undermined by being far away from family and being far away from the support that they bring, it's instead, I start to look at it as an opportunity to become more independent. Another thing, I realize I'm great at traveling. Like, that actually makes sense, So it's turning weaknesses into strengths. And then I kind of landed on this ultimate realization that basically home doesn't have to be a place. If you're not fixed in one physical location, that's also fine. Like, there's nothing wrong with that. I think that's something that my dad told me when I was around about 12, and I kind of it went in one ear, out the other, because I kind of just wasn't really into that. But as you grow up, that's just a thing that you learn. Home kind of just revolves around people. And I want to, because I've got time, apparently, I want to finish on one of my favorite song lyrics. It's from Talking Heads. It goes something along the lines of, home is where I want to be, but I guess I'm already there. And I hope that resonates with someone here. So, cheers.
Thank you, Tom. I thought home was one of those keys on the keyboard just above the cursor keys. What do you call an elephant that doesn't matter? An irrelevant. Obviously. And just to, you can't top that, so I give you Mr. Chris Oldwood.
Hey, don't clap too early. You haven't even heard these yet. Well, some of you are at 2016 probably haven't. Okay, strap yourselves in. Another set. For Christmas, my wife bought me a second-hand jigsaw of some computer scientists. She was a bit worried there might be some pieces missing. It took a while, but I proved it was Turing complete. You know the level now. Actually, of all the British scientists, Turing was definitely my favourite. In fact, I'd say he was the bomb. When Sherlock Holmes talks about a three-pipe problem, does he mean one that has grep, awk, sort, and unique? I'm old enough to remember when passing the output from one program into another was just a pipe dream. I thought it was odd when I visited the doctor and he said that a spot of programming might be good for a migraine. And then I realised he said codeine. Actually, my doctor would be a really dangerous C programmer. He thinks anything that's broken can be fixed with a cast. I also visited the optician as I had keyboards, printers and mice out the corner of my eye. I just realised it was peripheral vision. I visited the dentist too. He said I had a scaling problem. I said, that's awkward. I haven't got any more capacity for more teeth. I always thought Python was a much nicer looking language after 2.4. I guess that's when they brought the decorators in. It's good because there's a few Python people in. Is a standalone Python script known as a Jaffa because it contains no pips? C++ comes with complexity guarantees. If you use C++, it's guaranteed to be complex. We're getting there now, yeah. Do you know, I often think of myself as a pragmatist. If I get any compiler errors or warnings, I just pragma them out. Whenever I see static used in multi-threaded code, it makes my hair stand on end. Always make version numbers palindromes, because then they'll be backwards compatible. If you want your code base to be healthy, stick to natural numbers. You know, whenever I try and spell Octothorpe, I just make a hash of it. If you're thinking about taking a career with lots of self-improvement, I suggest going into topography. It's character building. Some people are like the char data type. They get promoted for no apparent reason. You know, my wife and I have been together for 25 years. I thought I'd get her a token ring. Can only get Ethernet these days. Have you noticed how McDonald's network cards all start FF, FF, FF? Is it because they like a Big Mac address? You can always tell when a telecoms engineer is running a marathon. They really struggle with the last mile. Is a cross-functional team an angry bunch of Haskell programmers? I've given up playing poker with functional programmers. All they ever do is fold. I recently built a robotic arm to switch cartridges in my Atari console. I think it's innovative. In fact, I'd say it's a game changer. If a self-driving car goes from London to Paris to Berlin and back to London, and no human notices as a driver, has it passed the Turing test? I think if we're going to make self-driving cars safe, we need to first solve the halting problem. Whenever I tighten the wheel nuts on the car, I can never work out whether to put the brace to the left or to the bottom. Let you think about that one. I was very disappointed with the second edition of Martin Fowler's refactoring book. The content was exactly the same, but the chapters were drifted in different order. I've started writing a novel about a 16-year-old who's disillusioned with the internet because he keeps having to prove he's not a robot. Thinking of calling it Capture in the RAII. If you deliver services via containers, does that make it Tupperware? I often find myself uncomfortable at meetups about dynamically typed languages. I'm not good at small talk. Recently, I had to give up trying to upload a picture of Marcel Marceau to a web server. I just kept getting a 415 unsupported MIME type. Thank you.
Oh. So painful, it was delightful. I can't top that. So I'll lower the bar. What do you call a factory that makes adequate products? A satisfactory. Next up is Mr. Greg Law.
Right, hello everyone. I've been coming to this conference for like 11 years. I think I've done a talk every time, except for COVID when it didn't happen. This is the first time I've sort of plucked up the courage to do the lightning talk, which 5 minutes of this is way scarier than 90 minutes of geeking out. So this is the title of my talk and my current mental state at the same time. So which code is better, the code on the left or the code on the right? Code on the left. So it's not a trick question yet. Okay, I think the code on the right is better. You should always check the return of malloc, right? Everyone knows that. Well, you might say, it's not really doing anything terribly different, so perhaps we'll, this is now, I think, unambiguously better. It handles the return type, handles the return of malloc and gives a nice error message to the user. Okay, what about this code? Code on the left or code on the right? Left? It depends, right? It depends. It depends on the context. Is this error recoverable or not, right? It also depends, do I have a test case for it, specifically an automated regression test for it? Because if when you run your code coverage, we all run code coverage, right? When you run your code coverage, if that return enomem line is not covered, then your error handling is broken, right? Not just there as well, all the call sites need to have a test case for that. And it's hard to test this stuff. So people say, well, you know, I mean, I know there are tools that can make malloc sometimes return null, but it's really painful. And it's not just malloc, it's every write to the file system. It's, you know, everything, right? How do you test all those error paths? And error handling is one of the hardest bits of programming. So it's almost definitely wrong. And if by some miracle it's not wrong now, it will be, right? Weeks or months or years in the future. So this is why I say test or panic, right? If you don't have test coverage is not practical, or you just can't be asked, like, panic. And then, oh, but I hear some people say we have exceptions, so it's a lot easier than dealing with all these return codes from C, to which I say bollocks, because like so much of C++, like so much of computer science, or maybe life, that we invent these exceptions to solve all these problems over here, which they do, and just create a whole bunch of new problems over here. And it doesn't matter whether you're like integer return codes or C++ exceptions or like Rust style. Like error handling is super hard, and if you're not testing it, it's broken. And your future self will thank you if you just panic. Right? And your customers or users will also thank you, because when occasionally it happens, you'll know the problem and you'll be able to get them a fix. By the way, this is one of the sort of design philosophy differences between the ill-fated Multics project and Unix, which sort of went on to take over the world, right? They didn't try to handle every single possible case, just added a bunch of panics. The reason that your future self will thank you is when you're debugging problems, there's two things that make it hard, right? Or two main things I think that make it hard. One is like, how deterministic is it? And it's already, like, by definition, a rare problem. It's an edge case, right? We already know that. And then the other is how long between the problem itself, the bug, and you noticing elapses. And the longer elapses, the harder it is. So you're looking for that place where reality has diverged from your expectations. And usually it's like more like that. So the closer you can get from the point you notice, the core file is generated or whatever, to the problem itself, the easier it's going to be for you to fix it. So, in summary, I think this is usually bad advice, as is this, although I would concede always take a towel.
Thank you, Greg. I just brought myself a chocolate record player. Sounds pretty sweet. Next up is Mr. Dom Davis.
Привет, товарищи. Меня зовут Dom. Learning Russian. As is probably obvious by people who actually speak Russian, I'm still struggling with the Russian alphabet, alphabet. I have my Russian co-pilot in the audience who will correct my many and myriad mistakes. Not much time, so let's carry on. There's 33 letters to go through. They are a lot more phonetic than the Latin alphabet, the English alphabet. I've heard English described as 3 languages wearing a trench coat. So let's crack on. This is A. We know it's A because we all know about da. So it's basically A with a Russian accent. Be. Looks a little bit like B, although we look at the cursive and what is going on there, the lowercase one is a D. Hang on, this is there. This starts getting confusing. This letter is an imposter. It's the V, ve. Ge. Looks a little bit like a stylized R, Greek origins. But what's really annoying about this is it can also have a ve sound. So Yevo is spelled with ge. Very annoying. De, which I call Space Invader, for obvious reasons. And again, looking at the cursive, lowercase g, yeah, and yo. There are a lot of E-shaped letters in Russian, and none of them make the E sound. But those two letters do actually make my favorite word, yeyo. Splat, the letter splat, or yeah, if you want to be pedantic. This is ze, basically 3. This is just what's going on now. E doesn't actually look like an E, but this is the E sound. And this is E with aspirations. This letter makes other letters sound like yet other letters, so I would argue is redundant. Okay, it's the first letter that's been friendly since A. La. I'll let that one go. I'm battle weary by now. Meh. That's a friendly letter. Nah. Now this one I don't actually have too many problems with because I also know niet. So I'm used to seeing that one. Oh, nice friendly letter there. This one would be okay. Greek pi, so I think P. But unfortunately, we then have this, which is re. It just throws my brain. But we should know enough now to know that this is not Pop-Cock-Mock. This is Roscosmos, which is the Russian Space Agency. So, arguably, British C makes a S sound sometimes. I'm going to lump this in with the set of letters that are not friendly. Many people lump it in with the friendly letters. This looks friendly until you look at the cursive. What the hell is going on there? It's like pi with extra bits and then an M. I'm not doing cursive. I hate this one. It's ooh. I keep putting a y sound in there because of what's going on. This one looks like Greek phi, and I also remember it as the focal plane marker on a camera. So this is the letter focal plane, or fe, if you're being really, really pandic. This one I hate. I'm actually going to have to go to my cheat sheet. All the way down there. I don't know, just don't get on with it. Tse, I remember this one as Tsetse fly. Yeah. Che, which I was told to remember as an upside down chair, which is bonkers, but it's worked. So, I mean, you know, did you spot the difference? I didn't. I would argue this is a diacritic mark, not a letter. This is hard sign. It kind of stops the previous letter from running into the next letter and doesn't do much else. I think it just sounds gangster, hard sign. I hate this letter. I can't pronounce it. And the only way I can really pronounce it is mish, which is mouse. Soft sign makes the previous letter softer, as if I know what that actually is. This actually is E. Sorry, have I got that right? Yeah, from Despicable Me, I have made a rocket out of macaroni. Crop circle, for obvious reasons, which is the U sound. And then my favorite thing here is the most Russian letter of all. The letter you look at and go, this is Russian. Has the most German sounding sound because this is the letter Ya. So now you know the Cyrillic alphabet and how to speak Russian letters. We'll do the Russian language in the next lightning talk. Spasiba.
Spot on 5 minutes. I mean, I don't know Russian, but even in the English alphabet, I only know 25 letters. I don't know why. Next up is Jutta.
So my name is actually Jutta, but it was close. Sustainable programming. There are probably various understandings or maybe also misunderstanding what sustainable or sustainability is. That's why I want to start clarifying what I understand of it. So I look at it from 3 different angles, starting with the social one, where we look at equity, fairness, livability. And if you think already a little bit in what we are doing, it could be something like diversity, inclusion, accessibility. If we move on to the next angle, it's about environment and the planet and how we can protect it. So maybe you think about the carbon footprint, and I'm not speaking of carbon, the programming language, by the way, the carbon footprint of the system you are creating. The third pillar is the economic or prosperity, which is about improving the life of everyone, everywhere. If you till now still think, what does this have to do with your work? I want to provide some examples. So, and everything is sustainability. And so the first example on the social aspect, this is an example of a system which required a registration of a person, but it also required 3 characters for the last name. Not very inclusive. Then the next example is, think about the software that you are creating and how often you expect the client to run the latest hardware, and it's not running on any old device, and because of that we are creating, or it's our responsibility that we are creating a lot of electronic waste. A third example for economic prosperity, well, this is where I'm coming from. I'm from Germany, very close to Volkswagen, and the Dieselgate for sure didn't work in the way that the software improved the life of everyone everywhere, just the opposite. So I think we need to think way more about what we are doing, and here is like an example what we can do. First of all, sustainable programming can mean that we use our programming skills to improve what's happening on the planet. So increase sustainability, and there are various non-profit organizations. For example, there's Developers for Future or Hack Your Future, and there are many more. So that's one thing we can do. Another thing we can do is we can use sustainability as a guide for all of our actions when we develop actually software. And so it can mean, again, that the carbon footprint is not increasing when we are doing our next delivery. And another thing is what we can do is we can start assessing our sustainability within our team. And for example, this could mean that we evaluate if we actually do know the full lifetime cost, life cycle cost of the software we are creating in all these different aspects of the definition of sustainability. Is this true for us, or is this false? And in the team, we can assess that. And another thing, if we look more on a social aspect, how much do we really prevent in our team discrimination, targeting, or disrespecting? Is this, again, false, or maybe it's true? So that would be good. And one of my favorites, which I really put in every once in a while, is I ask the question, what if the planet would be our stakeholder? And maybe it would change the way we are working, or maybe not. And the last example is that the product maybe can also inform before we automatically launch tasks in the background, which maybe are not used at all. So again, is this true or false? This is something we need to discuss. So basically, what I'm suggesting is we need to change our conversations in order to increase sustainability. Thank you.
That's awesome. I love prioritizing the planet as one of the stakeholders. That's great. What's the best smelling animal? It's a deodorant. Deodorant, yeah. Next up, Julius.
Hey everybody. So my name is Julius. I'm a performance engineer, and I want to just talk a little bit about perf. Anybody here Linux programmers? Yeah? Heard of perf? Yeah. So to connect to the previous speaker, about sustainability, how to make your programs more sustainable, improve their performance. Very simple, right? But it would be actually quite difficult to do. So does everybody have a clear understanding difference between what is performance and what is efficiency? Yes? Okay, so for those who don't, uninitiated, efficiency is how much work does your program do, right? And performance is how fast that work is being done, right? So you can improve the efficiency of your program, but you can make it actually worse, which is funny. So to connect, so a perf is basically, for Linux, is a sampling profiler. It interrupts your program. It collects a bunch of data from CPU registers, and it's a massive tool in a very small package. It's actually quite beautiful because it pretty much allows you to do anything. So I'm gonna cover just a few things that I think it's like essential to know. It's the stat record report, right? So what is stat? So stat -d is for more information, give me everything that you get. And we have everything about what your program was doing. Context switches, page faults, cycles, instructions, and then gigabytes of per second for branches, and there's tons and tons of information. And obviously we care a lot about the L1 and LCC cache misses, and then obviously the top-down FE bounds and B bounds, which is basically your front-end stalling, your back-end stalling. Meaning, I'm waiting for my instructions, or I'm waiting for data. It's like, come on, gotta move on, right? So, yeah, so to jump next, we will look at the record and report, which is basically getting the most. It's about recording a profile while running your applications. Seeing everything what it does. And there's a couple of things to look at. Compiling your programs with fnoa mid-frame pointer, just points, basically takes your stack pointer and attaches to a particular register. It's a bit more expensive, but you can actually understand what your program is doing. And G for call graph, it's basically I want to see it. And E for what kind of events I want to sample. The default, I think, is cycles, but you can say, oh, I want cache misses. I want to understand what's happening with where my front end stalls and whatnot. So you can look at all of that. So, and then the ability to annotate your code to look into assembly and actually understand what's happening. So let's look at that. So I ran record, and then at the bottom you can see perf record woke up that many times. That's how much data it collected. And then you run perf report with a call graph with -G. You can see the call graph of your application. You can inspect in detail. And then when you look at it, annotate it, you can actually see what's actually happening in your program. So obviously, this is just a basic allocator, nothing particularly interesting, but the information that you get here is not trivial. It's where your program jumps, what is expensive, what is not, and everything that you, I guess, need to know in order to improve the performance of your program. So there's a video which I created. It's about 20 minutes more about perf. If you care to watch it, I invite you to do so. And then if you have questions about perf, ask me over a beer. Thanks a lot.
Thank you. What do you call a fake noodle? An impasta. Next up is Nico.
Okay. What is the most important C++ feature? I want you to vote with me. So if you say, yes, that's it, yeah. If you say, no, say, no. If you say, I don't know, say, s. Okay? Good. Runtime polymorphism. No. Templates. Namespaces. References. Compile time computing. Range-based for loop. Crazy guys. Lambdas. Move semantics. I said most important, not that you like it most. Coroutines. Guess what? You're all wrong. The most important C++ feature are destructors. Why? Because if you look in the C way, in the way of imperative programming, programs that don't have destructors, then if you open a file and you want to later close it and you have to close it explicitly, you need a second function, but you can never wrap this in a way that you don't need the destructions or closing anymore. And what happens if we leave this scope? So with a destructor, we can say, oh, at the beginning, let's initialize an object, and at the end of the lifetime of this object, we close it automatically. This is famously known as the RAII pattern, and that is the pattern that makes a difference between C and C++. So the interesting reason why I have this talk, we had this yesterday, this discussion with Pete, and then we thought, oh, maybe that's an interesting question for this lightning's talks. So with destructors, you are able to implement the RAII pattern, and that makes a difference. Everything else is just syntactic sugar. And so with the destructor automatically being called, the question is when, so we can discuss whether finally has the same purpose. You can say, okay, I have here something wrapped, like members that automatically getting cleaned up, even if I have no destructor, and functions that use these classes when I leave the scope, whether it's on an exception or regularly, I close the files. So, thanks to destructors, C++ has a higher potential than C. Thank you very much.
Thanks, sir. Thank you, Nico. What I heard there is basically 99% of C++ is just syntactic sugar. This isn't related to Nico at all, but how many narcissists does it take to change a light bulb? It's just the one, they hold the light bulb and the whole world revolves around them. Next up is Akash. Give him a round of applause.
Perfect. So today we're going to talk about a ship called SS Richard Montgomery. And some of you may know about the ship, but for the benefit of the room, this is a World War II American cargo ship that sank in August of 1944. And the crazy thing about this ship is that it contains about 1,400 tons of explosives. So there is the ship on the right. And the crazy thing is, it's currently situated in Thames Estuary near Kent. And from the image, you can see that's London over there, very close to London. And on average, the wreckage is at 15 meters deep, which means it can actually be seen from the surface as well. So should we be scared about this? Sounds scary, right? So are we safe? Most people agree that if this ship was to blow up, it would be the largest non-nuclear explosion in history. There have been a lot of different attempts to try to have different solutions, but the discussion is that if anyone attempts to go on board to try to detonate some of the bombs or try different approaches, this could actually be extremely fatal. So what's the solution? Let's not touch it. Let's just let it be there. So I want to tie this back to software engineering, right? And I want to read a comment over here, which says, "Dear maintainer, once you're trying to optimize this routine and you have realized what a terrible mistake that was, please increment the following counter as a warning to the next guy. Total hours wasted here, 73. So similar to the doomsday ship that is just waiting over there, our code base has a lot of different bugs in it that one day could just explode. And there are a lot of different people that spend countless times optimizing different complex systems, right? Just like people trying to solve the issue with the ship. But the main issue starts with that this whole situation is extremely complex. And I want to take this opportunity to reference one of the books that I was reading that I found extremely useful, called A Philosophy of Software Design by John Ousterhout. And this talks about the fundamental issue of software development, which is complexity and how to manage that essentially. And it's inevitable that when software grows large, complexity is going to happen in the software, right? You have new functions, new requirements, different programmers working on it, but how do you actually contain it? So there are two key takeaways for me from this. One of them was, if you can figure out what the complex parts are of your system and understand and isolate them in a way that you don't actually change them a lot, you can make sure that it's hidden away. It's abstracted away in the sense that programmers, developers, testers, they don't need to interact with that a lot. The other key takeaway for me from this book so far has been this concept of tactical versus strategic programming. And essentially what it means is, if a programmer is a tactical programmer, it means someone who's extremely quick at creating code. So they're very quick at understanding the requirements and simply making sure you can churn out as much code as you can. But an issue with this happens where you try to think, it's just a small edge case. Maybe I'll introduce one or two small dependencies, I'll refactor somewhere in the future, but the issue happens, it's very hard to turn back once you start going this tactical path. On the other hand, you have strategic programmers, right? So these are the people who, before jumping into any project, they really think into understanding how to create software designs that is sustainable for the future. And this can either be proactive. So, when you have a project up front, you can really nail down the design spec, or it can be reactive. So when new issues come in, rather than having simple patches, you actually make sure you can create sustainable practices and make sure that the design is and the software is very sustainable for the future as well. So lastly, I just want to sort of tie this back with one of the talks given by Jutta as well, and I was in her sustainable talk yesterday, and I think this ties it back well with sustainability, because we need to realize that as developers, right, we're not just by creating inefficient, complex systems, we don't just waste our time, the time of other developers, but also it has a detrimental effect on the environment as well. So I think this is some of the key takeaways I took from this book and some of the talks I attended with this as well. And yep, that's me. Thank you.
Thank you. Does anyone else have a sort of terrible bent to see that boat blow up now? I'm reading a book about anti-gravity. It's impossible to put down. Next up, Mr. Phil Nash.
So it was 10 years and 9 days ago today that I stood on this very stage, one that looks very like it anyway. It's this room. I gave a talk called C++ Extension Methods. Maybe some of you remember it. Now, this talk was never recorded, and it's the only time I ever gave it, so I thought about doing it again sometime. But just recently, something happened that got me thinking about it again. So I'm not going to do the whole talk now, but I'm going to recap the essential points and then give you something new. So what was it about? So you may remember extension methods from languages like C# have this feature where you can effectively reopen a class and give it new methods or member functions a bit later. Many languages have this feature now, but not C++. Or does it? Well, consider this syntax. All familiar with this? You've got a pointer to an object and you want to call a member function on it, use this arrow operator. All familiar with this? We've got it from C. What if you could do this and use the left arrow operator, and that this would bind to something new? Well, we can't do something like that in C++. Can we? Well, let's take this class, widget, called it, and if you derive from this extendable base class, which is a CRTP template, means you pass the derived type down as a template argument. Don't need to do that in C++ 23, but I haven't updated these slides for 10 years. And then, if you want to add a new member function, you put it in a new class or struct, which itself derives from ext method, also CRTP, and you put the body of the function in a call operator. And if you do that, you can then use the left arrow operator to call that member function. It's like magic. So what wizardry is this? Well, this is actually all the code. Could do with some modernization. So it's actually two operators, the unary minus operator and the left-hand operator, working together to create the illusion of a single operator. So really it's just a big hack, and you definitely shouldn't do this in your own code. And if you do, don't put my name to it. And that was basically the conclusion of my talk 10 years ago. But There's a feature that's been bandied around the C++ community for some time now called uniform function call syntax. Has a long history going back, as you can see, to 2004, if you can read that. And this is more general than extension methods. This also gives you the ability to call a member function using member function syntax or free function syntax. Many proposals in that space have been tried over the years with different variations, but they all have one thing in common. They all failed. So when a new proposal came out recently in the same space again, the question was obviously asked, what's different about this proposal? What does this proposal have that those other ones didn't have? Actually, that's the wrong question. It should be, what does this proposal not have that the other ones did? Well, we'll get to that. But let's just see how it works first of all. Let's take our example of the widget class. We want to add a member function to it. Now, before I go on, I just want to recap friend functions. Familiar with friend functions, put the friend keyword there, and the free function has access to the private members of a class. Nothing new there. Although this has an interesting property. If it's all within the body of the class, it can only be found using argument-dependent lookup, which means that well, you get smaller error messages and the compiler does less work. Quite a nice feature called hidden friends. That's not what this talk is about. Now, C++23 introduced a new feature called explicit object syntax, which lets you put the this keyword in front of an argument, and that becomes the explicit this parameter rather than the implicit this pointer. Really nice feature, opens up lots of things. That's not what this talks about either. But this proposal says, what if you use both those keywords, the friend keyword and explicit object syntax? And this is now new novel syntax, never been possible before, so there's no backwards compatibility issues, which is what sunk all those previous proposals. And then you can call a member function using member function syntax or free function syntax for the same result. So not exactly C++ extension methods, but it may be part of uniform function call syntax that we might actually stand a chance of getting. So I think that's a worthwhile direction. Thank you very much. See you in 10 years.
Thank you, Phil. What do you call someone with nobody and no nose? Nobody knows. Next up, oh, there's an off by 3 error on the 10 talks you have tonight. So the first of the off by 3 error, next up is Joel.
Going to try and hold notes on a thing at the same time. Hey everyone, I have never been to any kind of conference before, so naturally I thought I would do the obvious thing and scare myself shitless by coming up here and talking to you all. So I am currently a software engineer, but my uni background was much more sort of theoretical computer science and philosophy. I have quite a disparate set of interests, and basically I'm an indecisive person. A generalist, if you want to be nice, but yeah. So 2 years ago, oh, empty slide, great. 2 years ago, I was finishing my master's degree, and for my main sort of project and dissertation, I wanted to marry together two parts of the computer science department at Oxford that had nothing to do with each other. They barely acknowledged each other's existence: formal logic and computer graphics. So anyone that's familiar with a bit of formal logic will know these kind of things. It's a sort of deductive proof system. This one's natural deduction, but it's like you infer things through a set of rules from premises. Yeah, it looks worse than it is, trust me. So what I decided I wanted to do was to try and map this to a 3D puzzle world. So to find a correspondence between the sound and complete proof system accompanying a propositional logic language and make it look something like this. This one's particularly messy. Don't know why I put that one in there, Jesus Christ. Yeah, basically, I think I played too much Pipe Mania as a kid, so everything turned out as pipe networks. But the idea is the variables are colors, and they get mixed and separated. It kind of looks something like this. It turns out it works. I wasn't sure it was going to work when I committed to doing it, but yeah, it turns out it works. More to the point, it's sound, and it's complete and expressively adequate for a finite variable propositional logic, because finitely many colors. But I think Yeah, it turned out all right. It turned out all right. The main thing that I wanted to pick up on, though, is that if anyone who did, a dissertation, a project, whatever, at uni, when you get into those final few days and weeks where it's really crunch time and you get really nervous, for me, it started infecting my dreams, my nightmares. I sort of found, skipping over this thing because I forgot I put it in, that this is how I did it. Yeah, great. It turns out that my dreams started looking like this. It was kind of weird. You start seeing these symbols and shapes and pipes all floating around together. But to be fair, that's kind of what the dissertation looks like. So thank you, dreams. I also got the chance to do a lot of cool geometric modeling, some of it procedurally generated. There's some cool rendering tricks in there as well. So constructive solid geometry there with the torus. There's parallax mapping, that's a really cool one. You give the sort of illusion of 3D. And then you also get a lot of stuff like this where everything goes crazy. Don't ask how many hours I put into fixing these things, especially when it came to writing custom shaders, because they are bloody hard to debug. Having said that, would highly recommend rendering and shader-based stuff if you never got the chance to play with it before. It's really cool, it's really rewarding, eventually. And I really, oh yeah, I also sent that with no context to my supervisor because I spent hours spotting probably the most terrible coding mistake I've ever made in my life. Now, a really pleasant surprise was actually in playtesting this with friends, with family, and a couple of students, because they actually got to grips with this really quickly in a way that they just wouldn't have done if it was all black and white, symbols on a piece of paper, despite the best efforts of my creative user interface choices. It's not part of the assessment criteria, so it's always a really hard thing to be bothered to deal with. And also this idea is extendable. This is a state machine that is like a delivery truck. I also quite like this teddy bear idea I came up with. It's actually a way of representing context-free grammars. You got to follow the robots like create more teddy bears. Anyway, some other takeaways from this. Teaching concepts visually and with interactivity is really cool and really important, really valuable. It's kind of like sneaking in stuff like a Trojan horse of the cool ideas that we geek out about. And yeah, marrying ideas from different departments, different fields, I think is really cool. That cross-disciplinary stuff, I think is really cool, and we should be doing more of it. Thank you.
Thank you very much. Why can't you hear a psychiatrist in the toilet? Because the P is silent. We're nearly there, people, we're nearly there. Next up, Stephanie. Keeping on theme.
Hello, hello. We are not just tied by rendering, but also I did philosophy minor in university as well. So thematically connected these two. Ray tracing on the GPU is the formal title because I pitched it to someone and they were interested in it. But the truth is, it's really Steph loves excuses to talk about rendering. So you may remember from my talk, I explicitly mentioned I have basically no artistic interest or ability. So if you're looking at this and thinking, but Stephanie, that is professional quality art, you should congratulate yourself because I took this from an NVIDIA presentation that was given at GDC just this year on path tracing. We can get into path tracing versus ray tracing later if you want. We're gonna stay on focus because I have 4 minutes and 5 seconds left. So we have light from a light source and it bounces around, and so that is the ray that we are tracing as it goes through the world, and that is how it works in the world, light from a light source. But the problem is that in the world, things like this happen, and if you're thinking that's not particularly useful or efficient in using our hardware resources, you're right, because the camera's over there. So we don't trace things in that way, we trace things as they are going backwards and collecting information. Now, we go tracing a lot of different things, see what's blocked from the light sources, see what's bouncing around. All of this is how we would think about it on the CPU. And that's how it's been used traditionally for decades. But we're starting to look at it on the GPU for games. We need to know a little bit about how it processes differently on the CPU versus the GPU. I think of the CPU, since a lot of computers have 8 cores, as the Fellowship of the 8, which is a lot like the Fellowship of the Ring, but after Boromir died. So the reason why it's like the Fellowship of the Ring is because each of the cores can do hero actions. They can think independently, they can communicate with each other, they can do really fancy things like out of order execution, branch prediction, really cool stuff. And the way that this CPU hides latency is by the cache system, which doesn't tie to the analogy, so we're gonna flip to go to the GPU. Now the GPU is more like an army. You have hundreds, thousands of different threads, and they're not able to do these hero actions. They are not able to do out of order execution. They are in lockstep. They don't do branch prediction. They must do the exact thing as the other. If there is a delay because you need to fetch from memory, then you rip off what is the current in flight and you throw on new threads. And so it covers it through just volume and covering the latency. So what happens with branches on the GPU? Well, if the last March of the Ents fills you with a little bit of sadness, then the image did exactly what it's supposed to do. Because on the GPU, it basically turns into, it becomes in series. So if you're gonna say that one half of the threads executes the first case and the other half executes the second case, then it's gonna go in order. First case and then second case, and it's gonna use all of those threads at the same time. So it's really inefficient. And that's a problem because when you go on the GPU, this is how we model ray tracing. See that beginning part? Oh, the lines, the white, they're not that clear, but they're all uniform and they make a lot of sense on the GPU side. Everything after that starts to branch, and it becomes particularly evil because some of these last a lot longer and have to go a lot farther before they find a light source. And that's where the problem is when you're in an army and you're all going together and you're trying to be efficient, it means that even if it's just because Joe went to the washroom, you gotta wait around. And so that's what happens with these long-lasting threads. And I have made it under 5 minutes. All right, thank you.
Thank you, thank you, thank you. You'll be pleased to know I've taken up snail racing. I bought myself a new racing snail. I wanted to make it faster, so I took the shell off. Just made it sluggish. Finally, it's Kevlin.
I'm here to relieve you from Pete. Yeah. Okay, so I'm keenly aware that I'm the last speaker and we're right up against the 7 o'clock deadline. I'm holding you back from drinks and food. If you've got any plans, let me know. Minor point of interest, that's a boutique pedal made in Cornwall, uses BC108 transistor, classic fuzz face style, but it's got a buffering section. Also, I don't own it anymore. We're going to talk about FizzBuzz, because of course we are. Because FizzBuzz was invented to avoid the awkwardness of realizing that nobody in the room can binary research an array. I mean, everybody thinks they can, but just count the off by 1 errors, okay? And yet, it's not just a toy problem. So the way that this was probably implemented, and we'll get to that in a moment, but if you're not familiar, just quick hands, like who's familiar with FizzBuzz? Yeah, those of you not, it is a drinking game, but if you go and look at the Wikipedia page, it says it's a child's game. Honestly, you really should not mix these two. There are morality questions and legal questions. The point is, it's a counting game. 1, 2, 3, but no, it's divisible by fizz, as it were. 4. Buzz, it's divisible by 5, and so on and so on, until you hit 15. Divisible by 3 and 5, it's fizz buzz. The idea is that if you get this wrong, then you have a drink, and it all goes downhill from there. Playing this drinking game without drinks is entirely dull. Do not do this. I have done this once. We were bored, we were waiting, and everybody was on point. We were fucking human calculators, and it's like, this is the most boring thing. Nobody's getting anything wrong. So this is one of the implementations people will come up with. So I'm going to present this in Python. People often come up with a kind of structure like this, and they kind of pride themselves on, oh, isn't that cool? It's kind of clever. I never have to handle a fizzbuzz case. It's a kind of like emergent side effect. Man, this is so stateful. There is so much complexity in 8 lines of code. It's ridiculous. This is the kind of implementation that gave us that tweet. There is also an implementation here. I'm not going to diss this one this evening. The use of implicit else. Oh, come on, people, get it straight. You will either find out my rant on implicit else tomorrow or next April, depending on how things go. Let's talk about this one. Okay, so I've got 2 implementations. They are the same number of lines in length. They produce the same results. They are both correct. They both pass the tests. But let's talk about coverage. Brian Merrick said, I expect a high-level coverage. Sometimes managers require one. There's a subtle difference. The problem here is this word. Whenever people use it, it's like they think they know what they're talking about. It turns out there's more than one kind of coverage, and we can easily fool ourselves. Let's take that first example. Thank you. Assert fizzbuzz 1 is 1. Okay, cool. So with that, we've achieved 100% function coverage, which basically means we called it. We have achieved 75% statement coverage. This is what people normally call coverage, but they never use the word statement. It's like there's only one kind of coverage. No, there isn't. There's branch coverage. Every if has 2 parts, 2 branches, okay? We have only covered 50% of the branches. In terms of full path coverage, not basis path coverage, which actually gives us the wrong answer, different talk, 25% path coverage. Okay, now, assert fizzbuzz of 15 is fizzbuzz. Boom, I have hit 100%. We can go home. Only 50% path coverage. You know there are 4 different kinds of result. We've gone and fooled ourselves. Let's go and look at this one. Fizzbuzz of 1. Okay, what have we got? We've got 62.5% statement coverage, 25% branch coverage, 25% path coverage. And another case, and we're still not at 100% on the statement coverage. And still not at 100%. And then finally, we achieve 100% on all the kinds of coverage that I care about today. It turns out that there is a fundamental difference between these styles. Okay, they have, I'm not telling you that you need to always labor out the logic, but I am telling you that it is incredibly easy to fool yourself. And you need to be very careful. The next time you use the word coverage, catch yourself and say, what kind of coverage? If you just say statement coverage, you've just opened up a conversation. Do the same with your colleagues. Thank you very much.
Thank you, Kevlin. When I was a kid, my dad got fired. He had a job as a road worker. He was fired for theft. I refused to believe it, but when I got home, all the signs were there. Okay, thank you very much. Let's give a final round of applause for Giovanni, for Tom, for Chris, for Greg, for Dom, for Jutta, for Julius, for Nicolai, for Akash, for Phil, for Joel, for Stephanie, and for Kevlin.